You've recently seen our work on the XE9680, which Jordan called his favorite server ever. That's a massive GPU beast. Now what we've done is come down to Round Rock, where we're talking with Dell about some of their latest GPU servers, because this is very much not a one-trick pony. They need solutions for all sorts of workloads, and what we've got today are some really cool things, including a liquid-cooled GPU server. So before I get too excited and dive into it, introduce yourself and tell us a little bit about what you do here.
Hi guys, I'm Mike Darby. I'm one of the product planners for the PowerEdge XE line, which are the GPU optimized servers. So I live with the engineers and the other planners who put out the portfolio every year.
That must be exhausting.
It's a lot.
Okay, so we've got two servers we're going to take a look at today. This one, is this your baby?
This is mine in particular.
Okay, and what about this one so special to you?
So it's cool because the types of customers I get to talk to and visit are a lot of fun.
Okay.
This being a dense 2U server running 4 SXM or OAM GPUs, which we'll get into, very high power in a 2U box. The customer in particular is one that is doing a lot of power per rack and a really cool workload. It is never not a cool thing you're doing with 4 SXM or OAM GPUs in a server. So
talk about that for a minute, because SXM or the OAM, we can talk through the differences of those GPUs here in a second, like you said. But how is this different than the slot-in cards, which most people are familiar with?
So you can think of like a PCIe GPU, taking NVIDIA as an example, the H100, same chip as the one that's down here on my SXM.
Right.
But when you put it in a PCIe, you're limited to the NVLink bridge of a 2-way today, and you're limited thermally to what a PCIe GPU gets you. So it's this big, I can only blow so much air through there. So the laws of physics are against you. That same H100, when you put it into the SXM form factor, now you can do novel thermal solutions to it, whether it's liquid cooling, whether it's an enclosed liquid loop internal to the server but air to the data center, or whether it's just a tall heat sink like you would have on a CPU.
Right.
Now I can crank that same H100 to 700 watts. So just
really let it go all the way, right? You're not having to...
It's like unthrottling the cores in your CPU you could think of.
And so just to set the tone, I talked about 9680, which is the biggest. It's an 8-way system. But if we're looking at the PowerEdge family, if you go down to your other 2U servers, like a 760 can support some GPUs, but you've got the XA version. So just talk about XA for a second and how that differentiates from what you're doing with these types of servers.
So XA is 2U. You can think of it like an R760, but it can hold 4 double-wide 350-watt GPUs, or up to 12 single-wide.
But now let's think about it this way too. So in that XA, you can fit 4 GPUs. I can fit 4 A or H100s in there. You've got 4 on this single SXM board, but there's still a little bit of nuance there between which one's right for the right workload, and that really comes to aggregation of these GPUs, right? So talk about the differences there in terms of that decision-making
So if
process.
you think about model size, if you have an H100, you have 80 gigs of high bandwidth memory. If you put 2 of them together with an NVLink bridge, they're effectively working coherently on the same 300, or 160 gigs over NVLink. So a high-speed connection between the two. When you come up to SXM, I still have 80 gigs in each GPU, but now I have 4 of them working in concert on NVLink. In aggregate, 900 gigabytes of communication out of each GPU to the pairs. In the case of the 4-way, you get 300 in each direction. But gigabytes, not gigabits. So you compare to PCIe Gen 5, it's much faster.
Right.
And so now I've got 4 times 80 gig. So I've got 320 gigs of gigabytes of where I can put a larger AI model, for instance, to work on all at once.
It's interesting too, because we've seen this not just in servers where the challenge is aggregating that graphics DDR, right?
Yeah.
But even on workstations, and I know you're not a workstation guy, but it's still, we see the challenges there where just necessarily some workloads, just adding another GPU doesn't necessarily double your ability to work on that GPU. Either the software's got to be tuned for it, or the GPUs have to be linked together in some way. And the SXM bit really takes a lot of that out of the equation automatically, making it easier for these guys to work with.
I mean, in any case, you're still pulling down, your CUDA container, for instance, or working in the case of Intel with one API. You generally have some footing to stand on before you jump in and try to harness that horsepower.
Okay, so this one specifically, I don't even know if I called the model out yet. What are we looking at here?
This is the PowerEdge XE9640.
Okay, so 2U, liquid cooled, but this is almost like 2 stories, or a server of 2 stories, right? You've got a top U and then a bottom U with 2 totally different things going on.
Yep. So we have in the case of the server, it's liquid cooled in that the CPUs and GPUs are liquid cooled. So if you think about the top U, you could imagine it being an R660 effectively.
Okay.
Because the top 1U is essentially that 2-socket motherboard. You got your DIMMs, your PCIe slots, and your drives in the front. If you get under the covers there, and we will in a little bit, you'll see the sort of the liquid-cooled GPU layer that is sitting under that motherboard. So the bottom U is essentially GPU and power.
Okay, and we're also, I mean, we love the GPUs obviously, but we're storage people too. So talk a little bit about, if you'll allow me to pull your bezel off, tell me about what's going on here from a storage options and capabilities.
So starting with the BOSS N1, the boot optimized storage solution.
Right.
So we have, you can go ahead and pop it off, it's hot plug. So at this generation, BOSS becomes NVMe.
Right.
And so I have a RAID 1 essentially just for OS. So I have node resiliency right to the front. I can lose a drive and not have to yank my node out or just come in here and pop this out.
We've always loved BOSS. I mean, the serviceability is pretty key. And now to go from SATA to NVMe is a huge jump.
Yeah.
Not that your OS needs that much performance, but that's where the drives are. That's where all the innovation is from a storage perspective.
And there's still a significant performance. I don't know about significant, but this because it's NVMe doesn't mean you want to do more than your OS on it. It is still designed for OS.
Right.
But over here I have 4 U.2 Gen 4 NVMe drives. So anything from read intensive 1.92 up to 15.
Right.
There's mixed use. There's all the different vibes. This limited to 4 here. In this same physical space of 4 drives, there's a post-RTS E3 chassis coming out with Gen 5 drives, where you can fit 8 drives in that same space. Yeah,
I was going to say, if I know anything about Dell lately with the PowerEdge in these Gen 16 platforms, is that E3.S, little narrow SSD form factor is really where you're making the investment for Gen 5. And I've seen this little 4x chunk before. I mean, this is something that you're using in other platforms to be able to leverage similar parts, or same parts, I guess in this case, to make it easier across many servers in the family, right?
Yeah, there's a lot of leverage. In fact, the motherboard that's in this system, you'll see in the next system we see later, it's the same motherboard that's in the XA. It's the same motherboard in the 9680, and it's a modified version of the motherboard in the 660, 760 mainstream, where the only real difference is that we had to present more by 16 PCIe, where the Swiss Army knife servers needed more by 8s.
Well, quit teasing it. Let's rip the lid off and see what's going on underneath this thing.
So, standard PowerEdge 16G motherboard, like you would see on other platforms, slightly modified in that we're presenting more by 16 PCIe slots sticking out. You can see there.
Right.
But 2-socket, 32 DIMMs. It's Intel, Xeon Max, 4th generation, Sapphire Rapids.
With a little bit of more hosing than typical in a PowerEdge server, right?
And you'll see in a minute where all this hosing goes. Okay. But so this server is, being 2U and the amount of wattage in it, it is liquid cooled on the CPUs and the GPUs underneath 100% of the time. So this is not, unlike the other power servers, these are not optional in this server.
Right.
This is always here.
Okay.
And you can see that normally there's a cover on top of this. We took it off so you could see it, but this is also a cable run to feed these PCIe slots, 4 of which are here, and just various connections that need to exist. We'll run through here and some going underneath.
So additionally, though, you've got the tubes that are obviously quite there and noticeable, sure, and then like you said, there's space for the cable runs for the PCIe connections to the back. But you also have leak detection. You've got some other intelligence built into these little modules, right? Yeah,
you can see a little bit of the leak detection peeking out in here. The cold plates are a monolithic piece where the bottom of the cold plate rests on the chip with thermal paste like you would expect to see on a normal heat sink. And so the liquid is entirely contained in that system and never touches anything, obviously. But just for everyone to feel safe, there's leak detection there that iDRAC then picks up, fully integrated to iDRAC.
Tell me about that. How much, for customers that have adopted liquid, they've already made the jump, right? The HPC deployments or other big customers that are leveraging dense GPU systems, they're not worried about that so much. I think they've lived it long enough to understand the benefits.
Well, they're they're worried about their total cost of ownership. They're worried about their electric bill. They're worried about the fact they're a limited power budget.
But they're not worried about leaks.
No, I mean, the growing pains have happened, and Dell's not trying to put something out there that they're not confident in. It goes through a lot of rigor before it gets out there.
Well, the funny thing is, though, I mean, enterprise IT has had liquid back to the 60s, right, in mainframes, and they went away for a long time, and so now what's old is new again. Obviously, this is a little more elegant than what was there prior, but the concern probably fades pretty quickly once you see the benefits of running a liquid system in your business.
Yeah, once you do it, you see the benefits and are able to do more with your money. So.
Okay, so what else are we looking at inside here? Because this has got another. We can see the SSD module here, but there's another big chunk here that's not commonly in a PowerEdge. Yeah,
so this right here, this is an early unit, so some of the boards are red, you can see here. Mm-hmm. But this board here is the power distribution board. There's 4 2800 watt power supplies here in the back, and it feeds in, and so you have to go 12 volt to the CPU, 54 volt down to the GPUs. And so this board is involved in that, and there's some cables, removed here, which you'll see a version of down below.
Okay.
So one thing about the server being that it is so dense, and the fact that we have our RAID 1 for resiliency on the BOSS, these drives there's no perk option on this server. And the customers buying it, frankly, don't want those to be. They just want scratch disk on that space. And so the reason there's no perk, however, is because this thing had to fit here because there was nowhere else to put it. Because underneath this board here, this is in particular the NVIDIA version layout of this chassis, NVIDIA GPU version, because there's a slightly difference between the two. There's a PCIe switchboard under here with 2 Gen 5 144 lane PCIe switches that everything essentially hangs off of as the hub. So the GPU can go to the PCIe slots to this storage without having to necessarily go through the CPU and use GPU direct with NVIDIA. So because that's underneath there, the power board had to go somewhere, so it went up here and ate my perk space.
Exactly. So before I let you, we're going to take this whole panel off here, or this what do you call this? A daughter board? What do you call this
just
chunk?
The storage tray.
Okay, just the storage tray. All right. So we're going to take that off here in a second. Before we do that, though, you do still have fans in the system, but these are just the 1U fans. It would be, like you said, in a 660.
Yep.
And that's really designed to drag the air across the front, cool the DDR, whatever is in your risers, and of course your storage and your power distribution in the front. Do they get to run a little lower than a 660 though, because we're not worried about cooling the CPU?
Yeah, I mean, they still say high performance fan on them, but they're not going to run at 100%.
Right.
Certainly. So it's definitely a lower load, not having to worry about the CPUs in here.
All right, now I'm excited about seeing this tray come off because we haven't done that yet.
All right, let's do it. I will just set this aside.
I feel like that was somewhat anticlimactic. It came out nice and easy.
Well, but it revealed so much. So
there's a lot for sure. So obviously we've got the GPUs here, but what are we looking at?
So pictured here is the H100 4-way board. Looks shockingly similar to what the Intel would look like in the same space. Covered up by the Cool IT cold plates. And if I do a little bit of a further reveal here, there's a nice little tell you what goes on under here. That is
there we go.
The secret sauce of how you get this thing to work in a 2U.
So this is what you wouldn't let me look at a couple months ago.
Yeah.
It was too early, but all right. So this is pretty sweet.
So coming from this one in and one out, it comes in underneath the motherboard to this manifold. And then we have, similar to the external quick disconnects that are entirely dripless, you have the same thing going inside, just a smaller version.
So this splits out to, what does it look like, 12 or so, 12 cables or 12 tubes, and that covers your 4 GPUs and then the CPUs in the system as well.
Yeah. And you can see that everything's getting its own cold going out in a single series back to heat into the manifold. So no one is sharing heat here.
Well, that's an important distinction, right? Because we've seen some loop systems before where it's a line that goes and hits everything, but by the time
the second GPU gets hot or warm.
Right, from item 1 to in this case 6, you've got a much warmer line by the time you get to the end.
Yeah, and I mean, it's possible to do such a design and have it be perfectly fine within the tolerances, but in this case, we were able to do it without even having to consider that. Every CPU is on its own loop, GPU is on its own loop.
Right.
And there are a couple things that are on the loop as well. You'll notice, for instance, there's some voltage regulator things going on underneath this cold plate that's part of the 4-way board, but not a GPU itself. So
right. And you were talking about the electrical distribution before. We're seeing some of that come here from the back. So talk about that maybe a little bit and why the GPU power management is so important.
Yeah, I mean, so again, 4 700-watt power supplies here. I've got 2,800 watts of GPU power just in this little tiny space. And so you have to feed that.
And that's not, so if you're thinking about like a gaming PC that takes a couple of those 8-pin adapters, it's basically that times monsters.
Here's my version of an 8-pin adapter, this big thing here. So now while we're on the liquid portion of this, we mentioned the little runs of leak detect going on top of this cold plate. There's also
you can see it running straight down the board, So
you'll see this little rope essentially running around everywhere that liquid could possibly occur, and that is again plugged in the same way to iDRAC leak sense.
I know we're so focused on the front, but now I'm thinking I/O. How do I get stuff in and out of here? What are your customers putting in your riser slots, and what are you supporting back there?
So I have 4 Gen 5 PCIe slots, a full height, low profile. And so again, I have 2 chassis, one with Intel GPU, one with NVIDIA GPU. So I'm going to just talk about the NVIDIA one first. The cabled run, for example, well, I guess it's not actually plugged in, would come right off of these risers through here and goes under here actually.
Tucks back in.
Which is the same thing that this board is plugged into with the blind mate connection you'll see on the GPU board in that close up. So underneath this motherboard here is that Gen 5, 2 Gen 5 switch board that these connect to. So the GPU can get to these PCIe slots directly without having to hop through that CPU. And what that means is that I have a 1-to-1 by 16 Gen 5, so up to 400 gig of bandwidth, in a InfiniBand, for instance, or Ethernet. And so we see a lot of InfiniBand. There's also a lot of high-end Ethernet going in here. People do all kinds of different things. InfiniBand certainly pairs a lot in this space because when you're in that dense space, that low latency hopping between, because they're scaling out between nodes at that point.
Well, the HPC guys have been on whatever is fastest for many, many years. So IB has always been a great choice for that. And now we're seeing a great resurgence in InfiniBand with these types of servers in particular, right?
Yeah, the attach rate of InfiniBand to GPU servers is the highest attach rate of InfiniBand that we see. So.
And Fiber Channel is how close?
Fiber Channel is not validated on this platform.
Okay,
in fact.
So it's still 0. All right. Well, the
Fiber Channel is still hugely significant, just not in this particular space.
Understood. So in addition to the risers and the IB cards you might see going in there, you've got OCP support on this as well.
Yeah. So in the back, I mean, as we mentioned, essentially an R660 motherboard with a couple different PCIe pins, presented differently. But on the back, I still have my optional 1 gig LOM. I have my pick your own OCP card, out of the menu, and I have the standard iDRAC port. So
while we're here, you talked about this box supporting both NVIDIA SXM and then an Intel option as well. The boards themselves are dramatically different. In fact, this Intel one's a little longer, and I question your ability to actually fit it inside here. So tell me about that a little bit.
Yeah, because we have sort of distinct U's going on, where the motherboard U up top is sort of the top one U, and the bottom U has, essentially power supplies, either a PCIe switchboard or power distribution board, and the GPUs itself. There's plenty of volume underneath to slide either here. But as you look at, so NVIDIA H100, SXM, 4-way. On the 4-way board, NVLink is just direct on the board, nothing. You remember the 8-way board, there was an NV switch to do it. So SXM, when you talk about the Intel, this is the Intel Data Center Max 1550, okay? So that's OAM, a different 3-letter acronym. OAM is part of that OCP, Open Cloud Compute type of thing. So both AMD and Intel do OAM. So you can think of that as being sort of more of a, not a proprietary form factor in that sense.
But still socketed versus PCIe edge card, right?
You
so
can
similar concept.
Yeah, and you can think of if you pulled this off, you'd see sets of pins that will remind you very much of CPU going down. So here on the Intel 4-way OAM board, we've got PCIe connectors here. That's going to cable directly up to the motherboard up top. In the case of the NVIDIA H100 board, I've got more of a blind mate that's going to connect, because on the NVIDIA version, there's a PCIe switchboard that this plugs into, and then everything hangs off of that in the case of the NVIDIA board. So the difference there being that NVIDIA has that GPU direct feature where you can go have the GPU access, RDMA directly out to resources without having to go through CPU. The key is that this is the first place that we've introduced the Intel 1550 OAM. It's very important to get that one API ecosystem in our portfolio. We're very excited about both of these being in this server.
But liquid isn't for everyone,
right?
Or at least a full loop. So you've got another option for those that want to get GPUs into their data center,
Yep.
But still do it efficiently, and we've got another 4-way system. So we just took a look at the 2U system, liquid cooled, full loop, but this one, I said it's not liquid, but it's sort of liquid. So what are we looking at here? What's this model, and what are we dealing with?
This is the PowerEdge XE8640,
Okay.
as opposed to the 9640. So you can think of the two units as cousins or brothers. The difference being that this one at 4U is air-cooled and intended for those who don't have facility water, don't want to deal with liquid cooling, and still want that 4-way H100. In this case, we don't have the Intel in this box.
Okay, and so when we take a look at this one, obviously it's a little bit taller to make room for that, but if we peel off the bezel here, let's start with where we started on the last one. What are the storage options on this guy?
So we have 8 of the 2.5-inch U.2 NVMe drives, so Gen 4. You can also do 8 of the E3 Gen 5 drives as a post-RTS option coming, so not pictured here. And
this one's got a little different, though, with the fans in the front. This has got some big, chunky fan modules.
So these fan modules are the very high-powered blowing across a radiator that we have right here.
Okay, so as we're taking a look at this, it's a similar or the same board as the other model?
So yeah, this server is, if you think of it from the actual components doing the work perspective, it's identical with the H100 4-way GPU, the same motherboard, literally the same motherboard as the 9640 that we just looked at. It's just a difference of packaging it and where things live. Okay, and so I talked about the fans in the front that are really for the bottom, 2/3 or so of this system, but this has got much larger fans here, presumably because you're not liquid cooling the CPUs in this case. Yeah, not pictured on this sample would be your heat sinks on top of your CPUs, so they have to be a little beefier to blow across there, and it's also getting rid of the dim heat and the riser heat. Okay, and you just mentioned risers. So what's going on with risers here? More IB cards? I mean, whatever, there's a menu. It's open to your configuration, obviously, as with all PowerEdge. But the slots are arranged a little differently, but 4 full height Gen 5 by 16 slots. So you still have the exact same 1-to-1 GPU to I/O ratio. Right, and that balance is actually pretty critical, right, in terms of maintaining the alignment, port alignment, lane alignment, all that sort of thing. I mean, the flexibility too. I mean, not every customer wants their, InfiniBand radix to be, what would be implied by a number of nodes with 4 cards in each. So often they'll ship with just 2. You have that flexibility, but you can get up to as much as you could possibly feed those GPUs with 4. Talking about storage again, we've got BOSS support on this one as well. It's just around the back this time. Yeah, this is the shroud over the BOSS unit here, but it's still hot plug. Right. It's just rear accessible instead of front accessible. And then the same iDRAC, OCP, LOM, again, exact same motherboard presenting out the back with all of the tenets of PowerEdge. So for a customer using this device, or a data scientist, AI expert, they wouldn't know any different, right? If they're using this model versus the liquid-cooled 2U. No, once you're in there, it doesn't matter. This is purely for the infrastructure of the data center that the customer has. So this box entirely air-cooled from a data center perspective. Right. That we have the closed-loop liquid cooling on the GPU layer that we'll see in a minute here. But when you're planning your data center, you just have to figure out how much power to run to your rack for how many nodes you're getting. And you were talking before about the power consumption of those GPUs of being at 2,800 watts, for instance, on those H100s. For all 4, yeah. Right. So from the thermal load, you're able to get the same efficiency from the closed liquid air-cooled setup as you are with the full liquid. So you're not trading off any performance at all. No. You get full performance. I mean, the fans, you design these so that you don't run your fans at 100%. Right. And so there's headroom in there to make sure that that's possible. And the module here is a little less accessible, right? So we've yanked one out on the table. We'll take a look at that now. Yeah, just a matter of everything that's blue is something you can touch. There's a motherboard tray that could come out, but we didn't. A little extra effort to get there on this one. That's okay. Yeah. So we've got one pulled out on the table. Okay, so we've managed to extract an extra rig here that shows the GPUs, the radiator. Walk us through, as we've got it sitting next to the same module, or the same 4 GPUs in a different module, but both 4-way boards. What are we looking at here? So yeah, the same 4 H100s that were in my 9640 being direct liquid cooled here. they are still down at the chip level being direct liquid cooled. So this is a closed loop. If you've ever built your own gaming PC at home, this is a much more robust and enterprise version of what you would have.
So this will play
LED.
Crysis? Is that the
No LEDs, however.
okay? Crysis, yes. LEDs, no. Okay, fine.
Yeah. So you can see the copper items here are the cold plates themselves.
Sure.
And then there's a pump system that sends the liquid through this radiator. This radiator is where you can, you efficiently have all the fans blowing across a fatter radiator surface area than you would have got if you just lined up, the spec heat sinks on top of where they would have lived.
Well, it strikes me as this is not so different than some of the rear door radiators that you might see as organizations kind of move into a liquid loop where the whole door is made out of something like that all the way back with a ton of fans blowing against it. It's a well understood concept, right?
Yeah.
This has
and
been
I think
around.
it's efficient, as well as one of the reasons it's still a 4U server.
Also on this board, we talked a little bit about drip detection.
Yep.
On the other system. I can see the runs on the board here too with the water detection rope.
Yep. Certainly not to be something we expect to have to use in your deployment, but the
just in
rope
case,
is there just
right.
to make you feel secure, and it will alert iDRAC in the case anything happens. So the other thing that is identical, as I mentioned, that you expect the same performance out of these two boxes. It's only air cooling versus liquid. So the same connections in the back going to the same PCIe switchboard. So you still get that GPU direct capability if you choose to configure that way, where your local storage, your PCIe slots, your GPU all can talk directly without having to go up and deal with NUMA stuff. So again, just a matter of you get to decide if you want to liquid cool or air cool your data center.
So I guess the net takeaway then is the liquid bit gets you more density in the rack.
Yep.
So you can fit effectively twice as many GPU servers in a liquid cooled rack. But to be fair, especially in the enterprise, most haven't gone there yet. And so something like this with the closed loop lets you get some of the benefits, but still stay air cooled by total server definition, right?
Yep. And this server is somewhere around 5 kilowatts.
Okay.
The liquid cooled version is somewhere around 4.5 kilowatts. So even just the fact of removing the fans, because I'm liquid cooling, removes the per box load. So, filling up a rack with air cooled servers, even though it's for you and you can fit a bunch in there, there's a point at which you're going to want to stop air cooling things at a certain level of power per rack density. And so it really becomes down to how much horsepower you need and if you have the power per rack to consume it.
Well, we're just talking about this generation's servers.
Yeah.
The next generation, or maybe two, we're going to run out of choices. There's only so many ways to treat thermal load.
And we're still dedicated to making sure that there are air-cooled solutions as we plan the next generation. We're in the middle of that right now. I should have been in a meeting doing that instead of this meeting right now, but this is important too. So we're going to make sure that we still find ways to enable data centers without facility water.
All right, so we spent a lot of time looking at both of these new servers, understanding the benefits of Liquid in the 2U server, the Liquid Assist in the 4U server. Ultimately, there's a lot of choices, a lot of options, and we don't even have the 9680 sitting in here to an 8-way server, or the XA, which lets you use the Edge cards as well. The portfolio has really grown a lot when it comes to GPUs.
Yep. Yeah, we had 2 refreshes with the R760 XA from the R750 XA. The XE8640 over here is a refresh of the XE8545, going from A100 to H100. And then we entered entirely new spaces of the market with 2U liquid cooled for the dense customers with a lot of power per rack, and as well as with the 8-way you've already reviewed. So, whether you're a customer who is doing AI but doesn't need 8-way, and the 320 gig model size before you need to scale out is sufficient. In these servers in particular, both of these, the 4-way, there's a lot of demand that looks like traditional HPC, and the reason for that, part of it is the CPU to GPU ratio in that space when they're doing that parallel compute. NVLink is maybe a little less important, or XE-Link in the case of Intel, and they're chasing that raw performance of the cores that they're doing that sort of Slurm, more parallel computing out of, as opposed to aggregating the GPUs. So that you see in this space in particular of the 4-way, especially with dense, a lot of that HPC, but it's still very much a high-powered, capable AI box.
Well, it's funny though, because a lot of the enterprise workloads are starting to look more HPC-y, right? Because it used to be the supercompute show would be for nerds that are doing scientific research and curing cancer, things like that, right? But as valuable as that is, the enterprise now is, and I know Gen AI is the big thing, but this has been happening for a long time. We used to call it BI or business analytics or data science right before AI was the buzzword. But these systems are showing up, or systems like these are showing up in enterprises now that really have to rethink a data center alignment a little more than maybe they've had to in the past.
Absolutely. I mean, the different things you can do with AI or with just raw compute for modeling simulation is it's staggering how many workloads. We always have to pick a few to put on whatever marketing material we're working on, and there's too many to choose from.
How about the McLaren one? You guys can start there, right? The Dell sponsorship. I'm sure. I mean, it's funny though. Like literally, wind tunnel usage has certain restrictions of what they can do with the physical unit. But in the AI world, you can gin up a new front wing or make adjustments in the plates underneath, and now run it through sims on these systems.
Yeah, absolutely.
And it solves a lot of problems, right?
I mean, you think of traditional HPC as being very CPU bound and just scaling out cores in my rack, and now GPUs add like a whole other aspect to that with FP64 cores, FP32 cores, very specific for very complex math to do that kind of thing. You know, fluid dynamics, molecular, and all climate modeling, all the things before you even talk about AI and you get into generative AI, for instance. So,
well, we've done a tremendous job of taking these apart to the extent that we can. We've got them all exposed, and I suppose we'll have to put them back together. But most importantly, we're going to have to get hands-on one of these things, just like the 9680. So that's your next task, is to free up one of these systems and tell your customers to wait a couple weeks so we can mess around on them.
Sounds good. I'll get them on.
Yeah, you say that now. Everyone heard. He said, sounds good. We're going to get these things on.
Definitely try.
All right, definitely try. There we go. We've got a firm commitment of definitely try. The 9680, we've got a paper on that. We'll link to that in the description. We'll put links into these systems as well so that you can go explore those. But this is great. Thanks for taking the time and breaking this down.
No problem.
Appreciate it.
Thanks for coming.
Thank you.